Lesson 10.1 is geometric sequences and series. I would pause the video and write down these notes. So geometric sequence, we talked about sequences back in chapter 5 as a list of numbers with a common pattern, and specifically we looked at arithmetic sequences, which the common pattern was a constant difference or a common difference. You were adding the same value every single time. A geometric sequence is a sequence in which the ratio between each term and the previous one remains constant, which means you're multiplying or dividing by the same value every single time. And that value, we call that the common ratio, and use the letter R to represent it. We always represent it as multiplication, so if you're getting smaller, instead of saying like divide by 2, we would say that we would multiply by 1/2. So here's a list of 6 sequences, and we want to find the next term and describe a way for finding the next term. So go ahead and pause the video, look at these 6 sequences. What's the pattern? Sequence A, you are adding 2 every single time, so the next term would be 10. Sequence B, you're multiplying by 3 every single time, so the next term would be 81. Sequence C, you're adding the 2 previous terms to get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. So the next term would be 3 plus 5, which is 8. Sequence D, by the way, this is called the Fibonacci sequence. It's a special sequence. Sequence D, you're adding 1.5 every single time, so the next term would be 3. Sequence E, it's whatever the term number is squared, 1 squared, 2 squared, 3 squared, so the next one is going to be 25. And then the last one, you're multiplying by 3 every single time, so the last one is going to be 405. So how can you tell whether a sequence is geometric or not, and which of these sequences are geometric? So go ahead and pause the video and answer that question. So for a geometric sequence, if you multiply by the same exact value every single time, then it's geometric. So sequences B and F are geometric. The nth term, or the general term for a geometric sequence, follows the pattern u sub n is equal to the first term u sub 1 times your common ratio r to the n minus 1 power, because repeated multiplication becomes exponential. So for each of these sequences, we want to find the first term, the common ratio, and the 10th term. So go ahead and pause the video and find that for these 3 sequences. So for the first one, our first term is 2, and we're multiplying by 3 every time, so r is 3. So then for the 10th term, I did u sub 10 was equal to the first term 2 times the common ratio 3 to the 10 minus 1 power, because we're going to multiply by 3 9 times. So you end up with 39,366. For B, our first term is -3. Our common ratio is -2 because we're multiplying by a -2 every time. That's why the sign changes. And then our 10th term, u sub 10 is equal to -3 times -2 to the 10 minus 1 power. You end up with 1,536. And then C, first term was 16. And then this time, since we're getting smaller, we're dividing by 2. Our common ratio would be 1/2. We always think about it as what we're multiplying by. We're multiplying by 1/2 every single time. So u sub 10 would be 16 times 1/2 to the 10 minus 1 power, which is 1/32, or 0.03125. For the next example, it says Caroline is starting a new job and she earns 48,000 euro in her first year, and her salary increases by 5% each year. We want to show that Caroline's annual salary follows a geometric sequence, state the common ratio, and calculate how much she will make in her 5th year. So to show that this was a geometric sequence, I found the first 3 terms. So the first term would be what she earned her first year, so 48,000. The next year she would earn that 48,000 plus 5% of the 48,000, so she's going to be earning 50,400. Then the third year she's going to be earning that 50,400 plus 5% of that 50,400, so she's going to be earning 52,920. So to get from one term to the next, you're always multiplying by 1.05. So the common ratio is going to be 1.05. So then to calculate how much money she's going to be making in her 5th year, I just plugged it into the general formula for a geometric sequence. So 48,000 times 1.05 to the 5 minus 1. Her 5th year, her salary is going to be $58,344.30. If you don't see the pattern to find the common ratio, in this case it was 1 plus 0.05 of whatever her salary was, so that's how we ended up with 1.05. the way that you can find the common ratio when you're given two consecutive terms is you divide one term by its previous term, and that will always give you your common ratio. So if I do 50,400 divided by 48,000, that gives us the 1.05. When it's tricky is when you're trying to find the common ratio and you're not given consecutive terms. So for this example, they give us the third term of a positive geometric sequence is 63, and the fifth term is 567. We want to find the common ratio and the first term. So there's two ways that you can do this. One way is to set up a system of equations and solve that system of equations. And then the other way is to kind of figure it out logically. So I'm going to show both ways. The first way I'm going to show is the equation logic way. So if I have the third term, in order to get the fifth term, I'm going to multiply by the same common ratio, which I'm going to call r, twice. I have to multiply by r to get to the fourth term, and then I have to multiply by r to get to the fifth term. So I'm going to take 63, and I'm going to multiply by r twice, which is the same thing as multiplying by r squared. And once I do that, I end up with 567. So now I can solve this equation for r. So go ahead and pause the video and solve for your common ratio. So I divided both sides by 63 and ended up with r squared to be 9. So then if you take the square root of both sides, you end up with r to be 3. And I know it's going to be positive 3 because they tell us it's a positive geometric sequence. So now we have our common ratio, and we can use that to find our first term. So there's two ways you can do that. You can either work backwards. If I multiply by 3 to go one way, then I would divide by 3 to go the other way. Or you can set up an equation and solve for the first term. So that's what I'm going to do. I'm going to set up an equation and solve for the first term. So if this is the third term and I plug it into the nth term formula, that means that the third term, 63, is equal to the first term, which I'm calling u sub 1, times the common ratio of 3 to the 3 minus 1 power. So 3 to the 3 minus 1 is 3 squared, which is 9. So I divide both sides by 9, and you end up with the first term to be 7. So that's one way. That's the way that I usually do it. The other way that you could do it is by setting up two equations and solving that system of equations by using your two different terms that they give you. So if you set up the two nth terms, we kind of did it over here. You'd have 63 is equal to u sub 1, which we don't know, times r, which we don't know, to the 3 minus 1 power. So one equation would be 63 equals u sub 1 times r squared. The other one would be 567 equals u sub 1 times r to the 5 minus 1, or 567 is equal to u sub 1 times r to the fourth. So now you have a system of equations with two variables and two unknowns, or two equations with two unknowns. So then you could use your graphing calculator and solve that system. It's a little bit trickier. You have to make sure you solve for one of the variables or whatever, but that would be one option, and you'd end up with the same thing. The next example, it says that Mr. Farmer buys machinery for $25,000 US, so that would be year 0 when he buys it. And the machinery depreciates at a rate of 8% per annum. So we want to find the value of the machinery after 5 years. So the machinery is depreciating, which means it's getting less money at 8%. So it's losing 8% every year. So when you think about your common ratio, I want you to think about how much it still is worth percentage-wise. So try and find the value of the machinery after 5 years. So if it's depreciating by 8% every year, that means that it's still valued at 92%. So your common ratio is actually going to be 92%. So just like when you are increasing by a percentage, it's 1 plus whatever that percentage is. When you're decreasing by a percentage, it's 1 minus whatever that percentage is. So then to find the fifth term, it's going to be 25,000 times 0.92 to the fifth power, because we started at year 0 instead of year 1. And so you end up that it's going to be worth $16,477.04. So then using this, try and find how many years it's going to take before the machinery is worth half its original value. So if you want it to be worth half of the original amount, that means that we want this to be equal to 12,500. And I set that equal to the general term. And then I'm just going to use my graphing calculator. So I'm going to set y1. I'm going to go into y equals, set y1 to be 12,500, set y2 to be 25,000 times 0.92 to the x. And then second trace, which is calc, go to number 5, which is intersect. You want to make sure you can see the intersection points, so you might want to adjust your window first. And then we find that the intersection is 8.31 years. Now, normally for sequences, we wouldn't accept that. We would say we'd round it up to 9 years, but depreciation is usually continuous. So 8.3 years would be okay. Now, if they're saying that, it only goes down on the year, then you would have to round it, something like that. But depreciation is usually a continuous function. Back in chapter 5, we also talked about arithmetic series, which was just an arithmetic sequence that you added up the terms. Well, we can talk about the same thing with a geometric series. So here's a little review of sigma notation if you don't remember the sigma notation. So remember, sigma means add them all up from your first term to whatever your nth term is, and then this is usually your general term. And it literally just means add all the terms up from 1 to n, okay? So then the sum of a finite geometric series, so you want to sum up the first n terms, is S sub n is equal to either the first term times the common ratio to the nth power minus 1 over the common ratio minus 1, or sometimes you will see these flipped. You'll have them written as 1 minus the common ratio to the nth power over 1 minus the common ratio. Either one, it doesn't matter. The formula booklet for IB shows both versions. Different textbooks show different things. So then for this first example, find the sum to 8 terms of the geometric series 7 plus 28 plus 112 plus so on and so forth. So if you do this by hand, your first term is 7 and your common ratio is 4. So you have the sum of the first 8 terms is equal to 7, the first term, times 1 minus the common ratio of 4 to the nth power, which is 8, divided by 1 minus 4. You end up with 152,915. If you use your graphing calculator, remember you go math and then you go to 0, which is summation, and then you type it into your summation formula so it would look just like this, hit enter, and you end up with the same thing. Next one says, when Kenzo starts Bright Academy, the school fees are Japanese yen 2,500,000. The fees increase 2% each year. Kenzo attends school for a total of 6 years. So we want to find the common ratio, the school fees in year 6, and the total fees that he pays for the whole time that he's at Bright Academy. So go ahead and pause the video and try this example. We are increasing by 2%, which means your common ratio is going to be 1 plus 2%, so 1.02 is going to be your common ratio. So then the school fees in the 6th year, it's going to be the 2,500,000 times 1.02 to the 6 minus 1 power. So the school fees in the 6th year are going to be 2,760,202 Japanese yen and 1 cent. And then the sum of all the fees that he's going to pay for the whole 6 years, I plugged it into the formula, and I ended up with 15,770,302.41 Japanese yen. For this last example, it says the second term in a geometric sequence is 6 and the fourth term is 24, and that all terms are positive. So we want to find the first term in the common ratio, write out the nth term formula, and find the sum of the first 10 terms. So go ahead and pause the video and try this last example. So I did the way that I did the one earlier. I said, okay, if I'm going from 6 as the second term to 24 as the fourth term, I would have had to multiply by r twice. So that means 6 times r squared would have been 24. So divide both sides by 6, you end up with r squared to be 4, so therefore the common ratio has to be positive 2, because they tell us that all the terms are positive. So then if the second term is 6 and I multiplied by 2 to get there, that means the first term would have had to have been 3, or you can set up your whole formula and solve for u sub 1 that way. So the nth term, u sub n is equal to the first term 3. What are you doing every single time? I'm multiplying by 2 to the n minus 1 power. And then summing up the first 10 terms, the first term times 1 minus the common ratio to the 10th power divided by 1 minus the common ratio, you end up with 3,069. So this has been geometric sequences and series.